Is it audible? Hello?
Yes, yes, sir.
Screen is visible?
Yes, sir.
Yes.
Okay. 3 and 9. So in the previous class, we have discussed some numericals on the PMMC instrument. So today we'll go for some range of extension of PMMC instrument, and after that one more problem we'll take that one more example, we'll solve that one. So here case 1, there are the extension of range of PMMC instrument here. This means what? We have suppose 5 ampere rating meter is there here. The meter rating is 5 ampere. We have one instrument here, but we have to measure 10 ampere current here. We know that one in a circuit more than 5 ampere, the supply is flowing here now. More than 5 ampere supply is flowing here now. So how to measure by using a 5 ampere? What is the multiplication factor we have to derive here? Okay, and for the voltage also, if it is 100 volt, 200 volt, 300 volt range is there, our instrument range, but the voltage supply, whatever the line we are going to measure, that is more than 400 volt, then by using this small rating of meter, how can we have to measure the higher range? Or by same instrument, how we have to increase the range of this instrument, we are going to discuss in the today class here. We are going to discuss in today class here. There are two cases are there here. Actually, PMMC instrument is used for the what parameters we can measure by using PMMC instrument? By using PMMC instrument, what parameters we can measure? Yes. We have already studied this subject in your diploma also. So yesterday class I also explained about this one. I'm asking to you people only. What parameters we can measure from the PMMC instrument?
Ammeter.
Ammeter. Next. So voltage and current we can measure by using the PMMC instrument. All of you know that one. So which voltage, AC or DC?
DC, sir.
Only the PMMC disadvantage is it is applicable only for the DC. For that reason, what we have to do here, maximum cases will come only we are going to measure voltage and current here. We are going to use this one to measure the voltage and current measurement. We are using this instrument here. So to extension of range of PMMC instrument, the range of voltmeter we can extend and the range of ammeter we have to extend here. Only two parameters. So two cases will come. Those cases are, one is we are going to call as shunt, another one we are going to consider as multiplier here. Based on the connection of the circuit elements, we are going to call the name, that is shunt and multipliers here. Shunts and multipliers we are going to call that one here. The first case we will consider here. The first case we will consider a low shunt resistance connected in parallel with the ammeter here. See here, first what I will do, I will draw the circuit here now. Okay, so just think that this is the instrument here now. Whatever the coil is there, this is the instrument which is connected to the power supply here now. Is connected to the battery supply, that is called V. I will tell that one here. Okay, see here the current flowing through here is I. The current flowing through this one is I here now, and the current flowing through this meter, that is called IM. I will consider here. IM I will consider here now. So for the sent connection, what we have to do? We have to connect one. We have to take one parallel resistance here and connect in parallel with the meter here. That is, this current flowing here is, that is called ISH. We can call that one here. The sent current we are going to call that here. So the sent resistance, whatever we have added here, that is called RSH, and the meter which is having the resistance, that is called RM, that is called meter resistance. This is sent resistance here. So current flowing through the meter is IM, current flowing through the sent resistance is ISH. We have used here. It is a parallel circuit or series circuit now? It is a parallel. Yes, parallel circuit. For the parallel circuit, the branch voltages are same or different? All of you know the characteristics of series circuit and parallel circuit. For the parallel circuit, huh? I'm not getting your answers. Come once again.
Voltage is same.
Voltage is same for the parallel circuit. If all the resistances for the series circuit, the current is same, voltage is different. Voltage drop across each branch is different. Here, this total V equal to voltage drop across RM equal to voltage drop across RSH equal to same here only. V equal to VM and VSH, you can call that one. See, one meter is there actually. So this meter is our 5 ampere meter. You consider that one. We have to extend the range here now. For that reason, one series, sent resistance is connected in parallel with the meter. One parallel resistance we have connected with meter here now. A low sent resistance here now, low value of sent resistance here. By the low value we are going to consider. If the resistance is low, means what will the current will maximum current will flow here? If the high resistance we have used, if I have used instead of low resistance, I will use high resistance. Then it will allow maximum current or low current?
Low current.
Everything is depends on Ohm's law only. V equal to IR only here. V equal to IR. I equal to V by R. V by R means if the resistance is maximum, then low current will be flow here. For that reason, the low resistance is connected in sent here. Now, because of this low resistance, the maximum current will flow in this resistance only here. So that is known value we are connecting here. Now, a low sent resistance connected in parallel with the emitter to extend the range of current here. Now, to extend this range of current, to extend that one, we have connected one low sent resistance here now in parallel with the meter here. Large current can be measured using low current rated emitter by using this sent connection here. Now, by using this sent connection, we can measure a large current here now. So let I will consider here now whatever this RM is there. RM is nothing but resistance of the meter. To measure the current, which one we are going to use, emitter or voltmeter? To measure the current, we are going to use which meter?
Emitter.
Emitter we are going to consider here now. So the resistance of emitter is RM here now, meter, and the RSH is nothing but sent resistance of the sent here now. IM is the current flowing through the meter, and ISH is the current through a sent resistance here now. And this I is total I. Here we have given the supply here now. This one I can use that positive and negative we have connected here now. That is called V. Total V. I will consider that one here. Is it visible?
Yes, sir.
Okay. So from this circuit, the VM is the voltage drop across the resistance meter here now, RM, and VSH is the voltage drop across the resistance RSH here. So Our resistance and this resistance are same only. The voltage is also same. The variable thing is ISH is different, IM is different. So according to these parallel circuit characteristics, we can say that V equal to VM equal to VSH. Yes, V equal to VM equal to VSH. We can say like this. Get right or not?
Yes.
So we know that VM equal to VSH I will consider here. No, according to Ohm's law here, VM is nothing but voltage drop across this meter here. No? According to Ohm's law, VM equal to what we can write?
IM divided by
VM equal to anyone? VM equal to what?
IM into RM.
VM equal to IM into
RM.
RM. Okay, IM into RM. VSH equal to the voltage drop across this resistance here, no, sent resistance. Which current is flowing in the sent resistance?
ISH.
ISH. What is the resistance value? RSH here, no. So VSH equal to ISH into RSH, VM equal to IM RM. But according to this parallel circuit characteristics, we know that VM equal to VSH here, no. Substitute VM equal to IM RM, I will substitute here, and VSH equal to ISH into RSH, I will substitute here. Here I will keep IM as it is here, no. This ISH is there, I will take into LHS side. It will become IM by ISH. IM I will keep here only. The ISH I will send into LHS side. So IM by ISH. And
Yes,
RM is there. I will send into RHS side, this one here now. So it will become RSS divided by RM here now. So by rearranging the equation here, IM by ISH equal to RSH by RM, it will happen here. So anyone, can you state the Kirchhoff current law? Any one of you, can you state the Kirchhoff current law? Yes, I'm
I
asking.
is equal to I1 plus I2.
I is equal to
I1 plus I2.
I1 plus I2. I am not asking you. Very good. You are telling that one for the basic circuit. You are telling the formula good only. I am asking statement only. State. Give the statement. Rule number 22. Amit Jadhav. Are you there? Rule number 22. So the algebraic sum of current meeting at a point or junction or node is equal to 0. Algebraic sum. So the here one junction is there. Just think that one, that is a junction here now. Some currents are coming towards here. Some so many currents are meeting at a point here now. Some currents are coming out away, going away, and some currents are coming towards the junction here now. So according to this, the algebraic sum of currents meeting at a junction equal to 0 is there. So the outgoing currents are considered as negative. The currents coming towards the junction is positive here now. Or all the current coming towards the junction is equal to current going away from the junction or node here. That one also we can consider. So that is a Kirchhoff current law here now. But according to that, here the junction phi is there. Junction P we are using here now. The applying Kirchhoff current law at this point P here now. How many currents belonging to this point P here now? This is here main current I is there. By providing the supply, This main current I is flowing here only towards the P. Yes, the current I is going to P here now, and from this P, ISH is flowing here. This ISH is also belongs to P point only. IML is also belong to this P point only. So from this one, which current is coming towards the junction? Incoming currents are equal to the outgoing currents. We can tell that one. Simple formula is there. Okay. From this point, you a point consider karo bhi, junction P. How many, which current is coming towards the junction? Which currents are going away from the junction here now? आप लोगों को डिस्कशन करना है क्या जस्ट एक्सप्लेन करना है वो बोल दो मेरे को क्लैरिफाई मी इफ यू क्लैरिफाई सर एक्सप्लेन करते जाओ क्वेश्चन मत पूछो बोलते तो आई विल कंटिन्यू यस इज इट ऑडिबल इज इट ऑडिबल
Yes, sir.
then tell the answer na क्या है मैडम okay this junction P we have to consider here now the currents meeting at a junction the algebraic sum of current meeting at a junction is equal to 0 so incoming currents are considered as positive outgoing currents are considered as negative so the current I is coming towards the junction current ISH and IM they are flowing away from the junction here now flowing away from the junction the current I is current coming towards the junction here now we can write the formula I equal to IM so incoming currents are equal to the outgoing currents we can write here now IM plus ISH are the currents meeting the algebraic sum of current meeting at a junction is equal to 0 that one also we can write like that I is current coming towards ISH and IM are both are going away so I minus IM minus ISH equal to 0 here 0 is these two equations are same only both the equations are same or not here I equal to IM plus ISH when you will send this one into this side I minus IM minus ISH equal to 0 you can write that one so both are same only here now so by applying KCL at point P we'll get I equal to IM plus ISH so from this equation we can go for the next we'll start that one so by applying Kirchhoff current law at point P you will get the formula I equal to IM plus ISH for this equation next what you have to do this equation is divided by IM here now the meter current kitna hai we have to divide that one here now so it will become I divided by IM I divided by this one I divided by IM equal to IM divided by IM by IM kitna hai 1 plus ISH by IM we keep as it is here now equal to this one I will keep as it is here now according to Ohm's law ISH equal to ISH equal to how much according to Ohm's law ISH equal to VSH by RSH yes
Yes, sir.
Yes, sir.
ISH equal to VSH by RSH divide I will use as it is IM equal to VM by RM But we know the formula here for the parallel circuit. We already know that Vm equal to VSH. We already know or not this one. Vm equal to VSH. For the series parallel circuit, the Vm equal to VSH. So here VSH is there, here Vm is there. So Vm by Vm you can consider, or VSH by VSH you can consider. Both will get cancelled here now. So 1 by RSH divided by 1 by Rm. We can call this one, we can write like this. Rm by RSH you can write like this. Rm by RSH. कंफ्यूजिंग मोड है तो मैंने लिख देता हूँ पूरा फार्मूला है. इफ यू आर गेटिंग कंफ्यूजन हियर 1 प्लस VSH divided by RSH whole divided by this one Vm divided by Rm. Vm divided by Rm. This is the formula is there. This one we can write like this. You can just check it down. 1 plus VSH divided by RSH into Rm divided by Vm. We can write like this. Yes.
Yes, sir.
So VSH equal to Vm. This VSH I can write as Vm here. No, both will get cancelled here. No, this one and this one.
Yes, sir.
So Rm by RSH 1 plus Rm by RSH is the left term here. No, so LHS we didn't touch it, that one. I by Im is LHS equal to 1 plus Rm by RSH is the right side. RHS side term is there as it is. Rule number 4 joining now. Okay, next, when I will send this Im into RHS side, it will become multiplied to this whole equation here now. So I equal to Im into 1 plus Rm divided by RHS here. So this Rm value is the meter resistance, we know that one, and RSH also we are adding some known value only for the in series in sent with the meter here now. So this is the multiplication factor for the measurement of current here. Our meter, this Im is the meter kitna reading dikhate, that reading here now. So by multiplication factor we have to calculate here and multiply with the meter value, we'll get the total value of current here. We'll get the total value of current here. So 1 plus Rm divided by RSH is called the multiplication factor. The sent resistance, whatever we are using, that is made up of manganese material. This has least thermoelectric effect. So the change in resistance due to the change in temperature is negligible. Because of the heat, the temperature will be very less, change will be occurs. For that reason, we are going to use the manganese material here. So what is the intention of this one is, suppose we want, if we have connected more than 10 ampere resistance, we have connected more than 10 ampere resistance we have connected. Just think that one here now. So I equal to हमारा meter reading कितना है, the ammeter how much it will read, that is called Im, total current calculation करने के लिए, plus 1 plus how much sent resistance we have added, that resistance value we have to write here now. Sorry, meter का resistance value already they will mention in the ammeter here now, Rm divided by how much sent resistance we have added here. By doing this one, what the multiplication factor we have to calculate, this multiplication factor we have to multiply into the meter reading, then we will get the total current here. Meter reading kitna hai, suppose 5 ampere ka reading meter hai, to up to 5 ampere only it will go, it is going to deduct here now. Suppose 3.2 is there, 3.2 use kiya humne. Okay, suppose just imagine that one, Rm equal to, I will tell that one, Rm equal to 2 ohm is there, RSH also 2 ohm, RSH also 2 ohm is there, RSH also 2 ohm is there. So our aim is to measure the current आवर एमीटर 5 एम्पियर का रेटिंग है, अभी 5 एम्पियर तक की रेटिंग है हमारा एमीटर का. सो IM वैल्यू अभी मीटर में वो डिटेक्ट करते 4.8 हियर नाउ, द 4.8. okay, 4.8 ampere it is going to detect here now. What is the total current here now? Total current I equal to how much? The formula you substitute here now. IM equal to how much? How much IM? 4.8 into 1 plus RM by RSH. 2 by 2 equal to how much? 2 by 2 equal to 2 by 2 equal to
1.
1. So 1 plus 1 equal to
2.
2. 2 into 4.8.
9.6.
9.6. So हमारा एमीटर रेटिंग कितना था? 5 ampere. I told that one emitter rating was 5 ampere. But how much current we have measured here now?
9.6.
9.6. So up to 10 ampere also we have measured. How it was possible? The way it was possible by adding this resistance value here, extension path. Some current we have bypassed through this resistance here. No, we have bypassed. Meter में कितना flow होता है? Only we are going to allow up to 5 ampere. Only we are going to allow into the meter. Whatever the excess current is there, by adding some low value of the sent resistance, we are bypassing this current here. Now that one we can multiply, we can measure by using a multiplication factor here. So that is called extension of range of PMMC instrument we are going to call it. If you have any doubts, you can ask me now. It completes the sent connection for the PMMC here, for the measurement of current here. Extension range of emitter of PMMC. Any doubts? If you have any doubts, you can ask now. I'm asking to you people only. If you have any doubts, feel free to ask me. Any doubts?
No, sir.
No doubts. Okay. Then we'll go for the next topic, that is called multiplier here. Multiplier we are going to call it. Now we have discussed previously, that is emitter range of extension. Now we will go for the multiplier. Multiplier we are going to use for the voltmeter extension for that one. The range of voltmeter extension we are going to use a multiplier here now. So what we will do, in the emitter, whatever the sent, we have used very small value of the resistance we have used to bypass the current here, bypass the current. But here we have to block the current here now. We have to block the current, whatever the voltage is there, that should have to drop in a resistance here now. For that reason, a large resistance is used here now. A large value of resistance, a large resistance is connected in series with a voltmeter here now. In series with a voltmeter we have connected here now. That is called multiplier we are going to call. A large resistance is connected in series with a voltmeter. Suppose here the DC supply is there. DC supply is there. Here the meter is there, meter high. Okay. Then I will add one small resistance, sorry, very large value of resistance here now. Very large value. This is V. This is VM, voltage drop across this one. This is VSH, voltage drop across this sent, and the resistance, sorry, RSC we are going to call that one. Just a minute, not VSH, VSC. This is series को हमने VSC use करेंगे. Voltage drop across this one is VSC, and the resistance of that one is RSC, and the meter resistance is RM only. And here the all currents are equal only. I equal to IM, current flowing through the meter, that is called IM, equal to ISC here now, current flowing through this resistance here now. So the only one current is flowing through the all the branches here, no, all the resistances, but the voltage drop across each value, each resistance is different here now. The voltage drop across each branch is different here now. So let this Rm is nothing but meter resistance. RSC is whatever the large resistance we have added in series. Large resistance we have added in series here now. What is it? No, no, sir. Amit Jadhav, now you are active. Okay. So one large resistance we have connected in series with the meter here now. So what is the operation of resistance? It should have to block the current. It will blocks the current here now. Then what will happen? Maximum voltage will drops across this resistance only here because of large resistance here now. V equal to IR, the current, and into this large value of resistance, it is going to drop here. So whatever the total voltage is there, this total voltage, some voltage will drops at this meter and some voltage will drops at this resistance here. Now by using this one, we can increase or we can extend the range of the voltmeter here now. A large resistance is connected in series with the voltmeter is called multiplier. We are going to call that one. A large voltage can be measured using a voltmeter of small rating with multiplier here now. Here the voltmeter we have used here with some multiplier we have added here. Let Rm equal to meter resistance. This one resistance of the meter. RSC is the resistance of the multiplier or series resistance, we can call that one. Vm is the voltage drop across the or voltage across the meter here now, voltmeter, and Vsc is the voltage across this series resistance. V is the voltage to be measured. Kitna voltage hai total? We have to measure this one. Unknown voltage we can call that one. And from this series circuit characteristics, the currents are equal or voltages are equal here now. According to the series circuit characteristics, the currents are equal or voltages are equal.
Currents are equal. Voltage
Currents
are
are
different.
equal here now. So the current flowing through this one, I equal to Im equal to Isc here now. So I equal to Im equal to Isc we can consider here now. According to Ohm's law, Im equal to what we can write?
ISC.
VM by RM.
Vm by
RM.
Vm by Rm. Okay. According to Ohm's law, Isc equal to Vsc by Resc. Yes. So here in the place of Im you substitute Vm by Rm, and in the place of Isc you substitute Vsc by Rsc. So this equation is over. Next, what do you have to do? In the previous cent, which law we have applied? Which law we have applied? Kirchhoff current law we have applied. Here for the parallel circuit we have applied Kirchhoff current law. For the series circuit, what we have to apply? We have to apply Kirchhoff voltage law here now. Kirchhoff voltage law here. The algebraic sum of the voltage drops across each resistances and the EMFs are equal to 0. EMFs are equal to 0 here. So here we have connected the battery supply. Just think that one, you have connected the battery supply here. Okay, this one I will consider as positive and negative, the sign convention, and this one I will consider as positive and negative here. No, according to this, I will apply the Kirchhoff voltage law in the clockwise direction here. So we can say that one here, the sign convention, this is the minus, which voltage drop is occurring here now? Vm, na? Minus Vm, the end sign I will consider. Next here, which voltage drop is there? VSC minus this VM नहीं दिख रहा है ना, VM minus VSE. The end sign is here, plus is there here. This is plus only, na? Plus total voltage VM equal to 0. From this, we can write V equal to VM plus VSC. We can write like this. Yes or no?
Yes, sir.
From this, V equal to VM plus VSC. By applying the Kirchhoff voltage law, we can write the formula for the voltage here now. That is applying Kirchhoff voltage law, V equal to VM plus VSC here. Okay. So to identify the multiplication factor, what I have to do, I will divide this equation by meter value here now. Meter means meter voltage here now. That is VM here now. So the LHS will become V by VM. The LHS of this equation will become V by VM. This is V by VM. Next, the RHS will be VM by VM equal to VM by VM plus VSC by VM here. VM by VM equal to 1. I will write 1 here now. VSC by VM, I will write as it is here now. So according to Ohm's law, VSC equal to already we have derived here now. The previous slide we can see that one. Previous slide we can see that. Okay. See here. This is VM by RM, not previous slide. What is? Okay. VSC by VM equal to VS equal to ISC into RSC according to Ohm's law. This voltage drop VSC equal to V equal to IR. So the multiplier voltage drop across multiplier equal to current flowing through that multiplier into the resistance of that one here. Now VSC equal to ISC into RSC divided by VM equal to, according to Ohm's law, VM equal to
IM into RM.
IM into RM we can consider here now. But for the series circuit, the currents are equal here now. So ISC equal to IM. So IM gets cancelled here now. The term left, that is RSC divided by RM here. So that in the place of VSC by VM, I will substitute RSC by RM here now. So V by VM equal to 1 plus RSC by RM. So you send this VM into RHS side, it will multiply to this whole equation here now. So V equal to VM into 1 plus RSC by RM. This 1 plus RSC by RM is the multiplication factor to the voltmeter reading here now. Voltmeter reading, it will the multiplication factor. You can say that one. So this is 1 plus RSC by RM is the multiplication factor. In the previous one here what is there? 1 plus RM by RSH is there. Here RSC by RM is there. Both are in reverse only. Multiplication factor. In the shunt, it was RM by RSH, whatever the meter resistance divided by the shunt resistance. But here the series resistance divided by meter resistance is there. Both multiplication factors are not both same. For the voltage multiplier, the multiplication factor is different. For the shunt, you can see here RM by RSH is there. Yes or no?
Yes, sir.
RM by RSH. For the multiplier, it is RSC by RM here. So by using this multiplication factor, we can increase, we can measure the unknown voltage here. No. Example, I will tell that one VM equal to 200 volt is there. Okay, VM equal to 200. The meter we are using here, the meter range is, the voltmeter range is up to 220 volts. It can measure up to 220 volt. It can measure here. Okay, just imagine it can measure up to 220 volts. I will tell that one the meter is showing 200 volts. The RM value, it is called 2 ohm is there. RM value is 2 ohm and RSC value is 10 ohm is there. Just imagine that one. RSC equal to 10 ohm is there. Okay, RSC equal to 10 ohm. What is the V here now? Can you tell anyone? What is the unknown voltage or total voltage here? Yes. Substitute here this formula. V equal to, what is the VM? 200 into 1 plus RSC is 10 divided by 2 here, no, 10 divided by 2. So it is nothing but 200 into 10 by 2. How much it is? 10 by 2 is 5. 5 plus 1?
6.
6. 200 into 6?
12,000. 1,200.
1200 volt. The unknown voltage we have measured here. Now, what is the meter range? Kitna tha?
220.
So the unknown voltage, by using the same meter, we have extended the range of that instrument here. Now, by using a small rating of instrument also, we can calculate the higher range value by using this cent and multipliers here. Now, the cent is applicable for the current measurement, series is applicable, sorry, multiplier is applicable for the voltage measurement here. Now, this completes the range of extension of cent and multipliers here. So yesterday we have, all of you have remembered the formula for the PMMC, the deflecting torque and controlling torque. Now I will give one more problem. All of you solve this problem. Take the last problem on PMMC here. Now a PMMC instrument has a coil dimensions of 10 mm into 8 mm, 10 mm into 8 mm. The flux density in the air gap is 0.15 Weber per meter square. Weber per meter square. If the coil is wound for 100 turns, carrying a current of 5 milliampere, then calculate the deflecting torque. First, you have to calculate the deflecting torque, that is called TD. Then calculate the deflection. If the spring constant is 0.2 into 10 to the power of minus 6 Newton meter per degree here. Per degree, they have given. Calculate this one. Will you calculate? Anyone? If you have the hopes, we can calculate. कोई कैलकुलेशन कर सकते, करके आंसर बोल सकते? Are you ready to solve this problem? Already we have solved 3 problems on this. Already 3 problems we have solved on this. So first you write the given data here now. PMMC instrument has a coil dimension of 10 mm into 8 mm. It is nothing but width into height here now. This is width into height. We have to write the area first. First you have to write area A equal to, they have given area A equal to 10 into 8. How much it is? 10 into 8? 10 into 8, how much?
180.
80.
10 into 8, 180. 80 into here also a milli is there, here also a milli is there. It is nothing but 10 to the power of minus 6 here. 10 to the power of minus 6, that is meter square. Meter square can use here. Next, the flux density in the air gap is nothing but B, they have given here now. B equal to 0.15 Weber per meter square, they have given here 0.15 here. If the coil is wound for 100 turns, 100 turns means number of turns is nothing but 100 here. No, that is called N here now. N equal to 100. Carrying a current of 5 milliampere here now. So I is 5 into 10 to the power of minus 3. 5 into 10 to the power of minus 3. What is the formula for deflecting torque? Find deflecting torque. They have told here now. Calculate the deflecting torque. So TD equal to question mark here. What is the formula for TD? We know that. We know that TD equal to NA BI. Yes.
Yes,
NABI. N is given here. N is given 100. A is given area. Flux density is given. Current is given. Substitute this and calculate here. Substitute this and calculate. कितना है आंसर?
6 into 10 raised to minus 6.
60 or 6?
6.
6. So we can calculate this by substituting this all value. You will get 6 into 10 to the power of minus 6 Newton meter per degree here. They have given in degree only, per degree. Okay, Newton meter per degree of deflection here. Next, what is the question? Calculate the deflection if the spring constant. They have given K, they have given here now. K equal to 0.2 into 10 to the power of minus 6. 0.2 into 10 to the power of minus 6 here. What do we have to calculate? Controlling torque or deflection means what? Deflection means what? Deflection means what? The angle of deflection you have to calculate, that is called theta here. Do you know the formula for TC equal to K theta? All of you know the formula TC equal to K theta. मालूम है formula ये? Yes?
Yes, sir.
TC equal to K theta. K is given already. TC equal to TD. Here you substitute TD equal to K theta. TD equal to K theta we can write here now. TC equal to TD. So from this equation you can write theta equal to TD divided by K. TD divided by K here now. The TD is we have calculated here 6 into 10 to the power of minus 6 and K is 0.2 into 10 to the power of minus 6. 6 divided by 0.2, how much it is? That is called this one here. How much it is? Six divided by 0.2.
Thirteen into 10 raised to 10.
How it will become 10 to the power 10? TD equal to how much? 6 into 10 to the power of minus 6.
30.
6 into 10 to the power of minus 6. K equal to 0.2 into 10 to the power of minus 6. So this upper side also numerator and denominator
30.
both side 10 to the power of minus 6 is there. This will cancel here now. So theta equal to 30. It is in degree or radian?
Degree.
30 degrees, because the spring constant they have given per degree here now. So the theta equal to 30 degree here. This is very simple problem we have solved here. The same you can see here. This is the solution also. whatever we got that one, I will show the answer also here. See here. TD equal to NBAI is there. N is 100, B is 0.15, A is we have calculated that is 80 into 10 to the power of minus 6, and I is 5 into 10 to the power of minus 3. So substituting all value, will get the deflecting torque is 6 into 10 to the power of minus 6. We already know TD equal to TC, TC equal to K theta. So TD equal to K theta we can use here. Now substitute the TD value here, 6 into 10 to the power of minus 6, and K is 0.2 into 10 to the power of minus 6 into theta as it is. So theta equal to 6 into 10 to the power of minus 6 divided by 0.2 into 10 to the power of minus 6. 10 to the power of minus 6 will get cancelled. 6 divided by 0.2 equal to 30. The angle is, the unit is degree here. So it completes the PMMC is completed now, and the moving iron instrument we are going to discuss in the next class. Is it clear? Yesterday we have solved the problems, but you have forgotten that one. Don't forget the formulas of this PMMC instrument, which will help for your ISC also. ISC may be both help hoने. Think about that and be ready for the ISC, first ISC also. Soon it may be after January end you will have the first ISC. Okay. So you have any doubts? PMMC is over now, and tomorrow we are going to discuss, that is moving iron instrument. We are going to start the tomorrow class. If you have any doubts, you can ask now. Roll number 15. पहले ही join होता क्या? So roll number 1 is absent, 5 is absent, 11 is absent, 17 is absent, 19 is absent, roll number 29 is absent, 31 is absent, 34, 36, 37, 38. These are the absent numbers. Once again, I will call the absent numbers. You can just check it. Roll number 1, roll number 5, roll number 11, roll number 17, roll number 19, roll number 29, 31, roll number 34, 36, 37, 38. So these are the absent numbers of the today class. So we'll stop here only and we'll continue in the next class. Can I stop now? If you don't have any doubts, no. Roll number 30 present. Roll number 30 is present. 31 I asked that one.
Hello.
हाँ बोलिए.
30 present.
हाँ 30 is present. No problem. Okay.